Let us start from the basics. First, we'll install the required modules for this notebook. Now, we'll import our modules and store the API key for the OpenAI model. In this example, we'll use chat completion, which is designed for text-based conversations. When starting a conversation with chat completion, we need to provide the following parameters: the language model, and in this example, we will be using GPT 3.5. The prompt list. We provide the model with a list of messages we want it to respond to. And finally, the temperature. This important setting controls the randomness of the model's responses. A temperature of 0 makes the model's responses specific, meaning that it will reply with the most likely outcome based on its training. As the temperature increases, the model's responses become more varied and less predictable. For this demonstration, we will focus on these three settings, although there are other options available for finer adjustment of the model's behavior. A large language model works by predicting the most likely continuation of the prompts it receives based on patterns it learnt during training. By adjusting the temperature coefficient, we can influence how predictable or how creative the responses are. When the temperature is close to 0, the model's responses are more deterministic and consistent. This means that if you send the same prompt several times, you will likely get the same or similar responses. This setting is ideal for tasks that require accuracy and consistency, like retrieving factual information or scenarios where you want predictable outcomes. A higher temperature, however, allows the model to be more experimental and creative in its responses. This is particularly useful when you need the model to generate content like stories or creative writing, where diverse responses are desired. However, the higher the temperature, the more random the responses become, and setting a temperature too high can lead to unpredictable and often irrelevant responses. Think of the temperature coefficient as a net for catching words. The higher the temperature, the wider the net's openings, allowing it to encompass and choose a larger number of words. Conversely, the lower the temperature, the smaller the net's openings, leading to a selection of fewer and more specific words. When interacting with OpenAI's language models through the API or the SDK, we send a list of prompts and receive a response. And it's important to note here that this interface processes the prompts and returns a response without retaining any memory. Therefore, to maintain continuity in the conversation, it is necessary for us to manage the context. This includes tracking prompts and responses for each session. Here's how we can manage the context. Storing conversation history. Since the programming interface doesn't retain conversation history, we must store the context ourselves. This includes saving all prompts and responses in memory with a simple list or in a database throughout the session. Adding new messages. With each new message from the user or a new response from the large language model, we add this information to the prompt list. Then, this updated list is sent back to the interface for the next interaction. In conversation management, we typically deal with three types of prompts. System. This prompt defines the AI's behavior or provides basic instructions that set the conversation's context. For example, we can instruct the large language model to act like a particular character or follow specific rules. Assistant. These represent the large language model's responses. Each time you send a prompt to the interface, you will receive an assistant message back, which is the AI's contribution to the conversation. User. These are the actual messages sent by the user, which the large language model is supposed to respond to. By effectively managing these messages, you can maintain a consistent and contextually relevant conversation with the large language model. Each interaction depends on the prompt list, so it is essential to include all relevant previous prompts to ensure the LLM understands the context. Let's take this example to illustrate the idea. First, we create a prompt list and call it memory. And the idea would be to save all interactions and messages within this list. Then, we add a prompt using system to define the AI's behavior or character. For example, we might instruct it to use pirate language in the responses and add another quirky feature that it doesn't like, mathematics. Based on these settings, all responses will take these directions into account. We then take the response on the model, add it to the memory list, prepare a new question and add it to the list as well. Let's take a look at the list so far. Right, now we will use chat completion again, but with the updated prompt list. As you can see, the new response takes into account my new message where I complained about its behavior, and therefore it gave me the appropriate response. Now, if you have used ChatGPT, Bing, or any other kind of chat before, you'll notice that the response is streamed to you rather than waiting for the complete response. Streaming the response in this way is much better, especially when you're using the large language model for long context tasks or tasks related to programming. Let's see how this works. We'll take the previous example and let the large language model stream the response token by token, which is like a word by word, using a generator in Python. Unlike lists and dictionaries that keep all elements in memory and then return them, a generator returns the elements, or in this case tokens, one after the other until completion. Now obviously, returning the tokens one by one might be slow. What we can do instead is collect the generator's results until we get 30 tokens, then send them, and so on. So how will this work? In Teams, where I've built my chatbot, I create a new message and continue updating it for every 30 tokens, and once finished, I'll update it one final time to get the final message. Check out the GIF.